I'm going to use the rational root theorem to choose what are the potential roots to solving this polynomial equation. So in order to identify the potential roots, I look at the constant and I write down all of the numbers that evenly divide into it. So what are the factors of 12 or negative 12? Plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12. Rational, meaning fractions, now I divide that by whatever's the leading coefficient, which is a 1. So I would divide this, so like 1 and negative 1, 2 and negative 2, 3 and negative 3, 4, negative 4, 6, negative 6, 12, negative 6. So 2, 4, 6, 8, 10, 12. There's 12 potential roots that can come from listing all the rational roots. I'm not asked to do that, but that does help me in deciding what I should test. So I'm going to start with a positive 1. Now the highest exponent I see, called the degree, is a 3. So I need some coefficient for 3, 2, all the way down to 0. Oops, that should have been a 1 and a 0. That's a 1. Okay, then I'm going to go back and I'm going to place the numbers of the coefficients that match up with each of these. So this is a 1, a negative 9. This is a 20 and a negative 12. When I teach this using the acronym DMUP. And what that says is we're going to start by dropping down the first number, and then I multiply, add, and you'll see it. Every time I multiply, it goes back to this number. So I've dropped down the first number, I multiply to get 1, I add straight down to get negative 8. I multiply to get negative 8, I add straight down to get 12. I multiply to get 12, and I add down to get 0. When this number equals 0, it tells me that this is a solution. That means if I plug in 1 to the equation on the left, the right side will equal 0. So I know x equals 1 is a solution to this polynomial equation. Now, I can see that we're going to have 3 roots. And later on, we'll learn about when those can be combinations of real and complex. So let's now identify the 2 other roots. Looking here, I'm able to now write a new equation. 0, and I put an equal sign in, and then I'm going to write down each of these numerical values. And it always works this way. The first number to the left of the equal sign has no x's. Then it has 1x, and then it has 2x. If there's another number, it'd have 3 x's. Okay, I need to solve this. It's a quadratic equation, so it means I can solve using factoring. Sometimes I can always use the quadratic formula. 1 times 12 is 12. What combines to give us negative 8 and multiplies to give us 12 would be negative 6 and negative 2. Now, because the leading coefficient is 1, this makes it very easy. Okay, so I'm going to set each of these factors equal to 0, and I'm going to solve to identify the 2 other solutions. So adding 6 to the other side, I get another solution of 6. Adding 2 to the other side, I get another solution of 2. So if I substitute in 1, 6, or 2, each produces an answer of 0.